Okay, great. I'd like to welcome everybody to Containerless in the Cloud. Just out of curiosity, how many of you have played with Lambda before? Okay, a couple of you. How many of you have Amazon accounts and use Amazon Web Services? Okay, most of you. So, in this presentation, by containers, I mean the traditional application containers. So, the presentation today, I'm going to talk about using Amazon Lambda to go containerless in the cloud, where we do not necessarily need Glassfish, Spring, Resin, etc. So, for the last 20 years, we've been developing our applications using containers, and Amazon Lambda will undoubtedly change this, as well as the offerings from Google and Microsoft that are coming out. So, in the past, you picked your technology stack and built your applications on top of that, and that's now changing. So, previously, or prior to Amazon Lambda, when we were talking about containers in the cloud, we normally talk about hosting our application containers up there on an EC2, putting Tomcat up there, managing everything ourselves, setting up the application container, setting up the execution environment, deploying the applications, managing the resources, tying it into RDS, creating virtual private clouds, and doing a ton of work to actually get a scalable application up in the cloud. And Amazon Lambda is changing this. So with containers, you have a number of lock-ins. So you're really picking a platform. You're picking a language to develop on, a tool chain, and an ecosystem of libraries and supporting code around it. So if you pick, if you decide to go with Glassfish or TommyE, you're picking the Java language to do your development on Java EE. So that immediately eliminates, you can't use utilities from Python or from JavaScript. And you're setting on, picking a specific set of tools to develop your application with, as well as the libraries that go along with it. So that's really, with containers, you're getting lock-in on a number of fronts. So now with the advent of Amazon Lambda, app servers are dead. Well, not exactly quite yet, as we'll see. There are cases where Amazon Lambda is not quite the solution or won't solve all of your problems. So the drawbacks to using containers are that they're overkill for many types of applications, especially small applications. They are hard to automatically scale. So if you have an application, you have a mobile application, and your back end is using an application container, and your application takes off, now it's your responsibility to try to scale the application, deploy it in different regions, manage data going between the different regions, correctly configure your JMS implementation so that it's high availability, that it's got fault tolerance. It's your responsibility to manage all of that. So it's hard to automatically scale. There's a complex programming model behind it, which sometimes blocks people or causes problems. So you can end up, some Java EE applications end up being large, highly complicated, and highly coupled applications, especially as they evolve over time, as well as one application. I don't know how many of you have seen applications where the entire application is one WAR file and it's gigantic. With the containers, you have maintenance contracts. So, scaling up sometimes involves purchasing additional licenses for the application container. And then you have a significant skills investment in terms of security, configuration, as well as a technology stack. So you have to know how to actually operate the container, how to correctly tune it, and that is all of your responsibility. So not only scaling it out, but also configuring it correctly and ensuring that security is done properly. So that's the drawbacks to using a container. In addition, with infrastructure, with using traditional containers, it's your responsibility to set up the servers, whether they're EC2 instances to set them up. If you're hosting in your own data center, you actually have to have data centers co-located around the world, dealing with managing the software for the VMs or for the actual servers themselves, configuring and knowing how to use monitoring tools and actually using them to get ahead of problems. Creating test environments that actually replicate what is going on in the real world with the application to verify that, when a million users start hitting your application or the load suddenly goes up, that the application doesn't grind to a halt, that you don't have certain performance issues with it. Dealing with IT support, you have to have people to monitor it and monitor the monitoring tools on a regular basis. As I mentioned, service contract. Data replication and policies. So if your application is being used in multiple locales around the world, you have to deal with replicating the data around the world as well and dealing with the policies that are inherent in that, because in some cases data can't leave a specific country or you don't want it going to a specific country. And then there is always the approvals. So if you're not in the cloud trying to get approval for additional hardware, additional test environments when you need it on the fly can be extremely challenging if you have to go grovel to an IT department or go request a budget for it. So the challenge I challenge you to for developing a traditional Java EE application is to develop a mobile backend that handles registration and authentication of new users using OAuth, going against both Amazon, Amazon, Facebook, and Google. Having built-in support with HTTPS so that it scales up, and having multiple sites around the world that can handle your application. Providing SMS notifications, RESTful endpoints for all the points of your application, automatic scalability around the globe, as I've already alluded to, having native code bindings for both iOS and Android to handle some of these functionalities to tie into your backend, managing versioning of the APIs, and also getting real-time monitoring. So these problems are basically infrastructure and services if you're trying to build an application. So that introduces Amazon Lambda, which is basically microservices without the app containers, without servers. So in the ideal world, what we want to be able to do is we want to be able to write our code, deploy it, and run it, and not spend tons of time with complex build systems, with packaging things together and to deploy it. Very oftentimes you spend a large portion of your day building the code and then waiting for the code to actually deploy and get warmed up so that you can actually use it, when all you're really trying to do is test a single function, a single simple function. And so, very often with this, it requires, you have to get different approvals for setting up test systems. There can be a lot that goes into doing this when, all you want to really do is, bang out a new microservice and get it up and running and not have to deal with complex deployment scenarios. And tying in with Lambda, and as we'll see as I go throughout this presentation, Lambda by itself is not terribly useful. It's the rest of the ecosystem that it ties into. All the other different Amazon services that you can hook into, for instance, Amazon Cognito for doing authentication up in the cloud, against like Google and Facebook. S3 for storing data, CloudWatch for monitoring the execution of Amazon Lambdas, identity and access control so that you can control access to resources and know what's actually going on, make sure that a given user has permissions to actually update that table in DynamoDB. They provide off-the-shelf dynamic databases, virtual private clouds, so you can set up basically virtual isolated instances of your application up in the cloud with restricting access to the database so that it's not on the web. So Lambda Basics, Lambda code is stateless. It executes in response to an event. You code specifically to AWS, so this is not a standard, so you can't necessarily take your code and run it on another cloud provider currently. You can how you get the code up to Amazon is you either upload it directly or place it in an S3 bucket. The code is fully managed by AWS once it's up there. It scales automatically, which means that when an event comes in to execute your code, Amazon instantiates it and runs it for you. You don't actually have to set anything up. It executes in an isolated environment, so you don't exactly know where it's executing or what type of exact environment it has. But it is an isolated environment. Instances may be reused. So if a Lambda function executes once every couple of days, well, obviously it's not going to probably be reused. Amazon will probably destroy it and then reinstantiate it later. You really can't make any assumptions about the execution environment. And at this, I'll have a slide further along, but the Amazon Lambda at this point doesn't tie into the code commit functionality yet, so that if you wanted to get like a continuous deployment environment, you'd have to actually use S3 with Jenkins running on an EC2 instance. So the programming model for writing Lambda functions is very simple. The handler is a function, is a function AWS Lambda calls to start execution of your Lambda function. It's kind of redundant, but it's the code that actually executes. It passes in, as a part of it, there's a data parameter, and then there's a context. The context is an object for interacting with Lambda, so you can find out how much time your Lambda function has left to execute before the container will kill it. Lambda functions generally have a finite amount of time that they have to execute in, and if you exceed that, Amazon kills you, will try again for 3 times, and then give up. So the context allows you to get different properties from the running environment. They provide built-in logging, so you can actually write logging statements out to CloudWatch so you can see what's going on with your Lambda expressions. Exceptions, so you can throw an exception out, which basically you're communicating back to the container that something failed. It'll try executing your Lambda expression at least 2 more times before giving up, as I mentioned. Now, there's several different models with invocation. So there's asynchronous, where no return value is sent back to the caller. So for instance, in S3, so if you put an object into S3, it's an asynchronous call. You don't return anything. Same thing with SNS and DynamoDB. For synchronous calls, you can return a value. For instance, you can return basically a JSON structure back to the caller. So in this case, that would be like API gateway, which I'll get into, and also the AWS console. If you're testing it, they're accessing it or invoking your Lambda function from the command line. So the security, as I mentioned, is provided by identity and access control. So you can set up fine-grained policies for who can invoke your Lambda function, that they have to be authenticated, and that ties into the Amazon Cognito feature. Lambda functions can start threads, access the disk, and as well as other AWS services. So your Lambda function can spin off 20 other threads to do concurrent processing. The default safety threshold, there's a default safety threshold of 100 concurrent executions per region. This is basically to make sure that your code doesn't go out of control. As I mentioned, AWS will attempt to invoke a Lambda function 3 times before giving up. And you can bundle external libraries with your Lambda function. So although it's a snippet of code, you can bundle supporting code. In the case of Node.js, you can include the other Node packages with it. With Java, it's obviously third-party Java libraries. So use cases for Amazon Lambda, for S3 plus Lambda, for combining the two, would be like image processing. Somebody uploads a picture, you want to take a snapshot of it and save that up to a website. Filtering, document analysis. So you have basically an S3 bucket that somebody uploads a PDF to, and you want to implement a Lambda function which will scan over the document, extract the text, and save it out for indexing somewhere else. Lambda with Kinesis, basically you can use that for transaction order processing, auditing. SNS and Lambda, basically, responding to alarms and event processing within your applications, which I'll get into a little bit later. DynamoDB. DynamoDB is the NoSQL database that Amazon provides. So with Lambda, that basically gives you the ability to have triggers. So if somebody inserts a record, you can have a Lambda function execute in response to that insertion. And then finally, you can tie Lambda into Alexa, which is that little thing that allows you to talk to, that device that allows you to talk to it. And you can kick off, as a result of invocations on Alexa, you can have them fire off Lambda, execute Lambda code up in the cloud. So there's a number of different use cases for this, and we'll tie it back to how it ties into Java EE as I go through the presentation. But the sky is the limit with it. You can do just quite a few things with it. The execution environment for Amazon Lambda, so there's the AMI, so you can get a sense of what the Linux installation looks like that your Lambda code is going to be executing on. So you'd use these AMIs, for instance, if you are your library uses, like your Lambda function uses some native code, for example. So if you are if you have a Java code that's calling JNI, and you want to make sure that you link against the correct native libraries, you'd build the stuff and test it on these AMIs first before you try deploying it to Amazon Lambda. In terms of the runtime versions, there are 3 different languages that you can provide your functions in that Amazon will call. One is JavaScript using Node.js, and they support 2 different versions of Node, an earlier version and then 4.3.2. Java 8, which is running the OpenJDK, and then finally Python. So those are the three languages that you can write the Lambda functions in. However, you can call out to other code. So you could have, as a part of the Lambda function that you upload to the server, you could have shell scripts. Your Java code could invoke Python scripts, call native code, call a native application that you've bundled with your application as well. So there's quite a few different things that you can do. So for instance, for your Java, you could use something like OpenCV for doing image processing. So you could include the native libraries with your Java package, and that gets deployed and executes. And then for the actual execution environment for Node.js, they include ImageMagick is installed with the default settings, and you have the Amazon SDK for JavaScript is also installed. Python, you've got Python version 1.3. For the Java runtime environment, there's no additional libraries that are installed, so you'll have to bring anything else that you want to use with it. So the event sources for Amazon Lambda that will kick off your Lambda expressions, so it can be Amazon S3 data from Kinesis, DynamoDB, like I mentioned, with triggers, CloudTrail notifications, SNS notifications, HTTPS via the Amazon API Gateway. The Amazon API Gateway is a way that you can basically define web services and then hook it into Amazon Lambda. So you can go into Amazon API Gateway, define the web services. It exposes the web services using HTTPS. You don't have to deal with the certificates for that at all. It gives you a URL that's scalable with load balancing. You can also have custom application logic that invokes it. They do have Java libraries that allow you to invoke Amazon Lambda directly. And you can also schedule Lambda events to execute at specific times. One use of this would be Amazon Lambda will keep your Lambda expression running for a period of time, basically keep it warm. So if you ping it on a regular basis, you can guarantee that you don't have to go through the startup process again for the Amazon Lambda function. Okay. Amazon Lambda functions, they do support versioning. So there's the basically you're always working with the latest version. So new Lambda function gets basically the latest version. Lambda functions have basically a unique ARN, which is an Amazon resource number, which uniquely identifies it. And there's two for each Amazon Lambda function. There's two ARNs. There's a qualified ARN, which has the version number in it, and then the unqualified one, which does not have the version number in it. And newer versions must be explicitly published. So when you upload newer code, so if you have your Amazon Lambda code in S3 and you upload newer code, you still have to publish a newer version of your Amazon Lambda function. So it's an explicit publishing that you have. Okay. In terms of pricing, the first 1 million requests are free. And then it's 20 cents for every million requests after that. So as long as you don't write, a script that tries to execute 1 billion times, you're okay with the pricing. So it's two things. There's the pricing versus the request, and then the duration of how long it executes. And then there's the free tier, which is 1 million requests at 400,000 gigabyte seconds. So it's pretty hard if you're playing around with this to actually ever exceed the free tier. So this is something that if you're not already playing around with Amazon, you can go home if you have an Amazon account, create an AWS account. It takes all of 5 minutes, and you can have code running up on Amazon in under 5 minutes. So between creating the account and executing, maybe 10 minutes, you'll have Amazon Lambda functions up and running in the cloud. And the real power with Amazon Lambda, as I've alluded to before, is Lambda plus all the AWS services that come with it. So just kind of a rundown of the services that I'll be talking about in the presentation if you aren't familiar with them already. S3 is the cloud storage, which I'll be tying into. So we can both deploy our Amazon Lambda functions to S3 as opposed to directly uploading them or coding them inline. And we can also tie that into deploying, and also we get event notifications, so we can have basically Amazon Lambda monitoring S3 for new uploads and then executing when somebody uploads data at S3. DynamoDB, which is a fully managed NoSQL database. SNS and SQS, which are simple notification service and simple queue service. You can't actually have Lambda invoked from SQS directly. There's several patterns that allow you to get in there to get it executing, to execute in response to SQS messages. Amazon Kinesis is a service for collecting and processing large streams of data in real time. And then Cognito, which is user authentication and management. So this allows you to basically front-end your Lambda expressions with the API gateway so that you can create, basically, allow a user to log into Google and thereby get access to your application. Okay. S3 overview. So the major features of our S3 is that it's secure, durable. The data is stored in different regions. You can have data managed between different regions. You'd use S3 for backups, data analytics, static website hosting, application storage of your Lambda functions, and the data that the Lambda functions is going to process or store to. S3, as you'll see when I get into one of the code samples, your data is basically stored in different buckets. The bucket names have to be unique, and that is globally unique. Okay, so each bucket name has to be unique globally. That's across all Amazon users. So the typical thing is that you pick your domain name, do a reverse domain name like you do with your Java package names, and name your buckets that way. There's a bunch of rules in terms of the characters that you can include with it. So for instance, in the demo code that I'm going to run today, I've got the code for my Lambda functions already uploaded to an S3 bucket called org.ct.java code, and then I've got the presentations that I'm writing, basically a PDF processor it monitors submissions to org.ct.java.presentations. When a new PDF gets uploaded up there, it processes and analyzes, pulls out the text in the presentation so that it can be indexed. Okay. DynamoDB is a non-relational database that also ties into Lambda. So Lambda provides basically the trigger support for that. So if a new record gets inserted into DynamoDB, it invokes your Lambda expression. And all of this ties in with the identity and access management, which is kind of cool with it. SNS is a publish-subscribe messaging service in the cloud. Amazon Lambda, you can receive Amazon Lambda. So as a result of a message going into SNS, you can receive a message from it and then process it. So you can have an unlimited number of messages be published at any one time. And this kind of ties into the functionality when I'm talking about the benefits of Lambda. You didn't have to set up a JMS provider in high availability mode in order to get this. You already basically have a queuing, a message publish subscribe system already configured that's global and that is scalable, that scales automatically for you, so you don't have to be dealing with, okay, you've exceeded, a billion messages have been published and you've exceeded the disk space and your ActiveMQ database is now corrupt. SQS, which kind of ties into it, is not integrated with Amazon Lambda. It's a fast and reliable queuing system. Data is secured against unauthorized users, and you basically feed SQS data into SNS in order to get it to Amazon Lambda. There's several different ways of doing that. Amazon Lambda can process data from Amazon Kinesis, which is is basically for working with large data streams. So it's meant for processing like terabytes of data, financial transactions, social media streams, etc. The records are stored for 24 hours, and you can replay them back. And it's fully integrated into the Amazon Elasticsearch. And then the one really important one is Amazon Cognito. So this does user authentication. This is a user authentication service. And so this would allow you, and they generate custom bindings so that you can use it in your mobile application, your web application, that allows a user to log into, say, Google, and then you basically, you know about that user then. So it saves you from having to do user management. As a part of it, they also do data synchronization. So you can store preferences data and application data, and that will work across mobile phones. So if the user logs in on an iPhone and logs in on an Android tablet, you can synchronize the data between the two of them. You don't have to provide any of the back-end infrastructure to do that. And so that all ties in. All of these tie in with Amazon Lambda and provide the ecosystem for building applications. So going back to that first example with Amazon Lambda, you have, the example application up in the cloud where you want to do authentication and have RESTful endpoints that get invoked. Amazon Lambda, you'd have the user would authenticate against Amazon Cognito going against IAM, either a federated database like Google or one that you provide. And then once they're authenticated, they can go in and invoke Lambda functions that then access DynamoDB. Probably the most challenging part about this is actually getting all of the policies set up correctly so that when the user logs in that they actually do have access to update DynamoDB, because your Lambda function, they might have permission to access your Lambda function, but your Lambda function might not have access privileges on DynamoDB, for instance. So it's a pretty strong security model in there for locking down your application. And then the nice thing about all of this, I grabbed a snapshot from Amazon. They have data centers around the world. And so you don't exactly know where your Lambda function is executing. It could be executing at any one of these. And I got burned prepping for this presentation that now I'm in Europe, so things were executing over here. And I had some data set up over on the US East Coast. So I actually pasted in a URL that would not work. So anyway, so your application, so you don't have to deal with any of this because they have data centers around the world and your Lambda functions are being executed in one of them. You don't have to deal with this. So in terms of Java EE versus Amazon Lambda and the Amazon services, it's not, Java EE is a standard, so it's nice in that you can switch between different providers, but it's not providing the infrastructure. So what AWS is a set of ready-to-made services, SQS, SNS out of the box. So these are roughly the equivalents between the two of them. You can kind of think of your Lambda functions as stateless session beans. However, you don't have the benefit of transaction. You don't have a transaction manager in there. You don't have dependency injection. So it's really small buckets of code. There's no equivalent between the Java EE world and like S3. From DynamoDB, you'd have to, if you were not running in this type of environment, you'd have to set up your own NoSQL database. And then you'd also have to deal with mirroring the data and deploying it across different regions. So that's enough talk about the background and the overview of Lambda. Let's look at some code and let's actually create a Lambda function. So I'm going to start off with hello world, canonical hello world, and we're going to do the first one in JavaScript just because that's easy to deploy, and then I'll go over a Java example which I've already preloaded up there. So if I go back to Amazon, so this is the same exact UI that you'd get when you log in to create a new Amazon function. Basically, they have templates that you can start with. And these are like a boilerplate code. So if you want to see, okay, how would I write code to do this? You have starting points for different basic recipes that you can start with. So we've got, doing node execs. An example of, doing working with S3 and Python. So we got quite a few. There's over 45, and they're adding new ones all the time. We've got an example with Twilio, SNS messages. So they have sample, and they also have Hello World, but they've got sample ones to get you up and running. So I'm going to click skip. So I'm going to skip that. Give my function a name. And because it's JavaScript, I'm going to stick with Node.js. I'm going to drop the code inline. Okay. And I have some settings here, so I have to select a role. So I've previously set up an Amazon role. This is just a basic one that comes with it. The maximum amount of memory I want it to use. The timeout. So right now it'll have a 3-second timeout, so it has to execute in 3 seconds, otherwise it'll give up. I can also attach it to a VPC. So where a VPC would come into play is if I'm trying to have my Amazon Lambda function talk to an RDS database like an Oracle database to update some records or insert some data. Click Next. Okay, this is basically summarizing it. And I can create the function. And just like that, I've created a function. Now I can test it. The ability to test it inline. Oops. Here. So my JavaScript function takes JSON going in. I can save it. I can test it. And so right now it's actually testing it. You see it's already executed down below. We can see that the duration took 20 milliseconds. They build you at 100 millisecond intervals, so I've been billed for 100 milliseconds of execution time. The total resources used to invoke this Lambda function were 36 megabytes, and you can see some other information right here. If we go up to monitoring, click on the monitoring tab, we can see how many times we've invoked it. We can see if we have throttling going on where it's had to throttle invocations because we've exceeded the 100 limit that I mentioned earlier. We can click over on CloudWatch, and you can see our logs over here. So if we were printing out log statements, this is the default logging that comes out with it. We can do basically, it captures standard out and standard error, so if anything went to standard out and standard error, like console.log in JavaScript, we'd see it here. Okay. And so that's executing. That took us, what, maybe 2 minutes to paste the code in here and click execute and get it running. So this is fairly easy to do. Now, if we want to get a little fancier, we have event sources. So that's invoking it manually. So we have event sources and APIs. So we can add an event source, which I'm not going to add. Event sources, as I mentioned before, as a result of a DynamoDB, a message from S3, SNS. We'll get into that in a second. But let's say I want to invoke this as a web service endpoint. So I can add a web service endpoint for this API gateway, which is the one that they support right now. And basically, I'm creating a end service. So I'm going to make it a get. Production, they have different levels of deployment stage, so you can have like test environments, production for your web services. So I'm defining a web service for this. I'm going to make it open for the world. So with AWS AIM, basically I'm tying into identity and access management. So I'd hook this into like Amazon Cognito, so you'd have to log in first in order to access the service. I'm just going to make it open on the web to make it easy to submit. As you can see, they display a little warning up here that it's open to everybody. So please don't go off and write a script in the back of the room right now that executes this a billion times. And we have an endpoint. So this is the endpoint. To invoke the application, I can go back over paste it in. Well, evidently I didn't make it public or something like that. Wait a minute. Ah, that was a post. It's probably going to complain because I should have, when I created the service, I was supposed to have created it as a post and not as a get. When I get to the Java one, I'll do it that way. But that's how you'd invoke it. You can paste this URL into your application and then use it there. Okay. So that's creating a simple hello world. So moving on to the Java code. So with Java, you basically implement a Java handler. The output. There's two ways of doing the handlers. There's either implementing an interface, or which is the second one, or providing a method and then specifying the class name and the method that you want to execute when the Lambda function gets invoked. You've got input, so you've got the input type into the function, the context, and then the output type. The output type is used for synchronous functions. So, for instance, the API gateway would be returning back JSON to the caller. And then the context object, you have a number of different methods on this, so you can get the resource that was requested, you can get the logging information, time remaining in milliseconds that your code can execute. Okay. For logging, they provide a built-in logger for you. You can configure log4j, but you have to make sure to include the log4j configuration file and reference their appender so that your log statements end up in CloudWatch. Okay. And then the Maven dependencies. So these are the dependencies in order to get the examples that I have up and running. So we've got the Lambda core, the SDK, And then I've got the Lambda events down there for pulling in like SNS events so I can receive events from the simple notification service. Okay, and then this is the Hello World example in Java. So as you can see here, I've implemented the request interface, and I have two objects, request and response. So the request contains the first name and last name, basically the same. This is equivalent code to the JavaScript code that I showed before, and then we return a response on the way back out. And coming in and going out, the Amazon Lambda infrastructure is converting the JSON into Java objects and back out. They're actually using the open source Jackson project behind the scenes to do the JSON to Java objects conversions. Okay. This is the request class. As you can see, it's just a simple POJO, which Jackson is then going to, matches up the names of the properties against what's in the JSON to give us the data. And then demo time. So deploying go back to Amazon Lambda. Create a Lambda function again. Skip the built-in templates. This time around, I'm going to select Java 8, which is going to run with the OpenJDK. And I'm going to select to use the code from an S3 bucket, which I've already uploaded, just to save us having to wait for the code to upload. Oops. This is the URL to the S3 bucket. I can show you the S3 buckets here. So as you can see, I've uploaded the code before. And the one thing with this code that it's actually an Uber jar. So this uses the, scroll down here to the POM file. So we use the shade plugin in Maven to basically generate an Uber jar. So if we had any third-party dependencies for this application, like say we were using Lucene or iText, they would all get bundled up into the jar file with our code, because everything has to go up there as a single jar file for Amazon Lambda. So that's where our code is. So as you can see, it's up there already in an S3 bucket. The handler function, I'm going to select right here. So I'm passing in basically the fully qualified name of the class, picking the same role as I did before. And this time around, it has a 15-second timeout, and I'm not tying it to a VPC. Click Next. And the one thing to make sure of is that when you upload your S3 bucket, to make sure when you're creating the Lambda function that they're in the same region. And then create the function. It takes a little bit longer to create this one because it's actually a 39 megabyte file that's up there. And so there we have it. We can test it once again. Nope. As we can see, it's running. This time around, last time it took, 20 milliseconds? It took 121 milliseconds to execute our code. We were billed for 200 milliseconds because we were over 100 milliseconds. Instead of roughly 36 megs, we used 69 megabytes of memory to fire up the JVM. That doesn't necessarily mean that JavaScript is always the solution because of third-party libraries, but for a simple hello world, obviously Java is a little bit overkill for this particular problem. Once again, we can go in there, we could define an API endpoint. We could, expose this Java class as a web service, and there we would have it. We wouldn't have to go, we wouldn't have to do any additional work, and we'd have a web service that's scalable, that can handle thousands and thousands of concurrent requests. Okay. One more example would be S3 notifications. So this is an example of an Amazon Lambda function that executes code in response to an upload to S3. So I had that example up there where I have the PDFs, the presentations where you upload presentations to. So here I can actually, I'll create this Lambda function and set and connect it. So I'm going to create a Lambda function again. Skip it. Pick Java. You can get that link from S3 itself. I just have it saved separately to make it easier. The function name. Now this one here, I'm not actually implementing an interface. So for this one here, I've defined my own method that I want it to call back. So I have an S3 notification method with named extract. And this is the syntax for doing that. So you can see I have the fully qualified name of the class. And then I have : and the method name that's to be executed. Amazon Lambda, if you had an overloaded method, is going to pick the one with the most number of parameters generally to match it. Pass in there. Select the role. We'll keep the same settings. Click Next. Okay, we've created the function. Now let's add an event source for it. So we want to listen to data that gets put into S3. Listen to S3. We're going to listen for anything that gets inserted to presentations, the event type. We've got several, so we can, if something gets deleted from our data store, or if something gets created, we can do some prefix and suffix matching. Create enabled. There we go. So we have an Lambda function, so if anything that gets inserted into that bucket will get executed. So let's go over to that bucket. Oops. Delete these first. Okay, I'm going to load another one. So there's a command line API, a Java API for inserting things into this. Okay. And so we've inserted something into our S3 bucket. If we go back over to Amazon Lambda, we can look to see if it's invoked yet. That view sometimes lags a little bit. Let's see what the logs have to say. Oops, it's been invoked already. And okay, I think it received it. That's not exactly what I expected. Received an event, so it did get something. So that's an example of S3. I also have an example of doing SNS notifications. You can do this for DynamoDB. So there's many different things that you can write. Okay, and as you saw with the CloudWatch, we can we can register. We can have Lambda events on log messages as well. So in response to a log message, we could have something looking for like a failure, and then kicking off a Lambda function to go send out a notification, for instance. And so in terms of the hello world versus the JavaScript, in the test cases that I ran beforehand, the hello Java was taking around 167 milliseconds versus 2 milliseconds for the JavaScript. So obviously it's optimized more for the JavaScript. But that's not necessarily, depending upon what you're doing, it doesn't necessarily match up. For the client generation, I didn't actually show a screenshot of this, but for the API gateway, we can have it generate binding code for JavaScript or for iOS. So it will give us basically a block of code that we can then include into our Xcode project or our Android project to then invoke our web services. And they also have code that for Amazon Cognito that will handle logging in and getting back the token that you will then pass in with your web services calls to handle that portion of it. So in terms of reasons to use Java EE, so when would you use Java EE versus Amazon Lambda? Well, if you're trying to do something with distributed transactions, like you want to get a message off and you only want the two-phase commits, so that would be a case where you do it. When you're tying into like Amazon Lambda or an SNS, your Lambda function may get invoked twice for the same data. So you really should be able to handle the fact that you could be getting duplicate events. You have to be aware of stuff like that. Long-running tasks. So if you're doing something like report generation, because I think there's a finite amount of time that an Amazon Lambda task can execute before it quits. So obviously something if you're generating reports, doing compute-intensive tasks, rules engines, things like that, those would not be a good match for Amazon Lambda. You may have third-party dependencies or applications that have to be installed that may have node-locked licenses. That would be another reason not to use it, to use a container. Integration with legacy systems, so if you're calling out to like TIBCO and sending off events to other systems. If you're using WebSockets, so you're doing some type of like streaming gaming or streaming application, Amazon Lambda is, it fires and then it quits. So there's no way that you can maintain like a bidirectional communication with the client. And then there's also legal and cost implications with it. So trying to figure out how much is this actually going to cost, especially for a large application, can kind of be tricky because there's data transfer costs for S3. There's different costs for everything. So there's calculators out there to try to help you figure that out. Third-party licenses for software may not allow it. And then regulatory requirements. So if you do have a security exploit or a security hole, being able to take a snapshot of that, because remember, you don't have access to the underlying AMI. You know what the AMI templates they're using, but you can't take a snapshot of the environment if there was a security breach, for instance, which may be required for regulations. And then in terms of architecture, stepping back at like a big picture, for developing applications using Amazon and Java EE, you could use, this is just a hypothetical, you could have like an use the Amazon Gateway API on top for providing access to your application, use Amda Lambda underneath for, getting a list of users or getting a list of documents that have been updated, whatever. But the cool thing with it, though, is that you're no longer tied to just implementing your code in Java. You can write parts of the application in JavaScript or Python. So if there's a particular library that you want to use for particular small running tasks, this allows you to write scalable applications up there that use these other libraries and other languages. You can still have the Java EE container running in the EC2 instance that ties into SQS and SNS for coordinating activities between the two of them. So you'd use your Java EE container tied into SNS, receiving messages from that to do data processing, and then tied into RDS, EC2, Elasticsearch. So instead of implementing your own search capabilities, you use like Elasticsearch. So you can build more scalable applications using this approach, combining Amazon Lambda with the containers. And so it gives you a bunch of flexibility that you did not have before. So in terms of challenges, one of the biggest challenges is documentation for the Amazon Lambda stuff. How exactly do you write an endpoint for SNS using Java? I can't tell you the number of hours I spent trying to get that to work. I'd find an example up there that somebody had posted on Stack Overflow, run it, and it would say, the method parameters don't match, and that's it. It doesn't tell me what it was expecting, what it was reflecting on. It just says they don't match. Testing can kind of be a challenge because you don't have, at least for Java, you don't have that type of execution environment that you can test. How is it going to invoke it? So you have to upload it to Amazon and have it invoke it. And so you might actually write Lambda functions that test other Lambda functions and have test environment. So it's a set of tools. It's not a fully fledged environment for building up stuff. Tooling support. Error handling can be kind of challenging. You have to write something to parse the log files. Right now there is no integration with the AWS code commit, which is kind of frustrating. So they've got this nice environments for you to be able to upload code, but there's no integration between it. With Node.js, the version is lagging. In terms of best practices, small archives containing code, you don't take your existing WAR file and expose a single web server, upload the entire WAR file that's 110 megabytes, right, to expose one service as a Lambda function. You want to just strip it all the way down to the part of code. If you were using Hibernate and that Lambda function is updating one table, you wouldn't want to have the thing starting up, analyzing your database schema, etc. So you'd want to really minimize that, minimize the startup costs. One way to minimize startup costs, if your Lambda function does have, some startup costs, is to periodically invoke the Lambda function to keep it warm, because they'll keep the Lambda function around for a while and then reuse it. So if you periodically poke it, you can get rid of the startup cost, because the startup cost versus the cost of poking it might actually be cheaper. and then monitoring logs for failures to try to get ahead of anything that goes wrong. Some good resources. They've got blogs up there on Amazon Lambda. The pet store application is a good one to look at, and that one ties everything together with Amazon Cognito, DynamoDB. So there's actually a tutorial that you can work through that will actually get you fully up and running with the pet store application. It comes with an iOS application, so you can see the code that's generated for iOS. You know, everything that I've talked about, API Gateway, DynamoDB, Amazon Cognito, all tied together. And so that's it for the presentation. And also encourage you to check out, there's a Java EE Guardians where we're trying to get Java EE 8 moving again, so check out that website as well. I have a side project that was mentioned yesterday, I believe, during one of the sessions. So with that, thank you. And if there's any questions.
Is it possible, like JSON serialization, can you use the Jackson annotations on an object when it gets serialized?
I think you should be able to. I haven't tried one of those extended use cases with that. I thought it was using Jackson by looking at the dependencies that Amazon was pulling down. So I've been, because the documentation is lacking, they don't say that they're using Jackson anywhere. I just noticed that that's in their SDK and that's part of the dependencies. So I've had to do a lot of reverse engineering to try to figure out what the heck is going on and invoke Lambda functions hundreds of times trying to figure out what's going on behind the scenes.
Do you think they're ever going to solve the documentation problem? Because you're right.
I have no idea. It's so hard to like track stuff down. I mean, the problem with their stuff is you have to read the blogs, you have to look at the code samples, the code tutorial. So it's like everywhere. There's not one place that even tells you, okay, here are the Maven, you know, the Maven dependencies. I mean, I found those by accident digging around and going through MVN repository, because you pick the wrong version of it and it's not the version that they're running up there, and it just says class mismatch and that's it. It doesn't tell there's nowhere that there's no notification that said, oh, in the last couple of weeks we changed the version on you, and so forth. So I got burned by that.
One of the first slides you mentioned about image processing,
Mm-hmm.
the use case.
For instance, one of the simplest example would be like generating thumbnails, right? So you want to generate thumbnails for a website or something like that, thumbnails of a user thing, or you want to do some type of analysis of the image to make sure that it doesn't contain objectionable content. So you're allowing users to post like a profile picture, and you want to make sure that it doesn't contain anything objectionable. Combining that with like OpenCV or something like that. Yes, I have it in GitHub. I haven't published. I have to push it yet. So I have it mostly there. I'll get it up there to Twitter. Is that it? Okay.